Yo, what's up my little caucus? Today we are going to start our chemistry Regents review kickoff, and you know what, we're going to go back to 2012, right when One Direction was dying, and we're going to look at this Regents. So without further ado, grab your calculator, grab your pencil, and grab your reference table. Because, girl, whatever you do, no matter what, you will always be beautiful. Let's do this! Day 1 review. Okay, so on today's episode, we're just going to be focusing on multiple choice. So, chill. I have some jazz music in the background. We're good. So, let's get down to it. Okay. Number 1. What is the number of electrons in a completely filled second shell of an atom? Okay. So when we see this, let's just draw a quick sketch. We have our first shell, which is comprised of 2 electrons. Second shell is going to comprise of, think that would be 8. So, what is the number of electrons in a completely filled second shell? When it means filled, it means 8. So 1 is 4. Number 2. What is the number of electrons in an atom that has 3 protons and 4 neutrons? Okay guys, remember, the number of electrons, write this out, equals the number of protons. Okay? So we're going to have 3 electrons because we have 3 protons. Okay? Number 3. As a result of the gold foil experiment, it was concluded that an atom, okay, when we think of gold foil, we think of, when we think of gold foil, we think, I think protons are, there are spaces in the electrons. I have trouble on the gold foil as well. But you know what, when we have trouble on a question, we can just, do some cross-elimination and we'll figure it out. Don't worry, I have the answer key right here, so we're good. Okay. It is a hard, indivisible sphere. 3. No. That correlates with, Dalton's, I believe. So we're gonna give that a D for Dalton. Has positrons and orbitals. Well, we haven't talked about positrons that much at all, because this is not a nuclear chemistry related question. 2. Contains a small, dense nucleus. Okay. 1 contains protons, neutrons, and electrons. Okay, you know, the gold foil experiment does not at all talk about neutrons, so that's an outie. Contains small, dense nucleus. Sure, because that's what it's kind of testing for. There are lasers, I guess, going through the gold foil, and it's to show that these spaces of like the light, not of like the light refracting or whatever, is gonna that those spaces of the light shows that there is some sort of nucleus going on. It's like hitting that nucleus. That's why the light is refracting or bending. Okay. Number 4. Okay, let's move this out of there. Which statement describes the distribution of a charge in an atom? Okay. A neutral, basically it's asking which is true. A neutral nucleus is surrounded by 1 or more negatively charged electrons. Okay. A neutral nucleus is surrounded by 1 or more positively charged electrons. Well, electrons are not positive, so cross that out. A positively charged nucleus is surrounded by 1 or more negatively charged electrons. Okay. That's a possibility. 4. A positively charged nucleus is surrounded by 1 or more positively charged electrons. Okay. Electrons are not positive, guys. They're negative. So what's the difference between 1 and 3? Well, we see neutral nucleus and positively charged nucleus. Remember, a nucleus is always going to be positively charged because of those protons. So 3 is going to be your answer. 5. Which atom in the ground state has an outermost electron with the most energy? When we think of most energy, that means they're going to have the least number of valence electrons. So let's go to our reference table and we're going to compare these. Well, right off the bat, we see lithium has only 1 valence electron in the second shell. Also, okay, so I forgot to mention that shells also have a big role in this, because the more shells you have, the less energy there's going to be, the less desire for the more shells you have, the greater there's like this the more prone an electron from the outer valence shell is going to be let go, because it's not as closely compact with the nucleus, which is positive. So for 5, we're gonna look. You have cesium, and this has 1. That's a lot of shells right there. So it's probably going to be more prone to losing that 1 electron, since of the so many shells. It's like not connected to the positive nucleus. So cesium is going to be that. You see with potassium, lithium, sodium, they're all in the same group. It's just cesium is right at the bottom, right above little Francis. Okay. Which particle has the least mass? When we're talking about least mass, we are talking about those small little particles that make up, protons, for example, or other make up the subatomic particles. So we're going to talk about subatomic particles. 6 is going to be 2, a beta particle, because I believe that the beta particles, they are the subatomic particles of the electrons. I'm not sure on this because we haven't talked about nuclear chemistry yet, but I'm kind of going back into physics, which I took last year, and we talked about this. But according to the answer sheet, 2, the beta particle is correct. Number 7. The elements in group 2 are classified as, okay, let's go to group 2. When we look at our reference table, know that group 2 goes down, period, goes horizontal. Okay. So when it says the elements in group 2 are classified as, well, when we see this in this area, this is going to be metals. Okay, you have metals. Metalloids are going to be over here. Non-metals are going to be over here. And the noble gases are going to be right in group 18. Okay, so the elements in group 2 are going to be classified as metals. So which list includes elements with the most similar chemical properties? Whenever we're talking about elements with the most similar chemical properties, that means they have to have the same number of valence electrons, pretty much. So which one has the same number of valence electrons? And when we're thinking about same number of valence electrons, we're thinking about which pair of these elements are in the same group. Okay. We have a bromine, gallium, mercury. They have nothing in common because they don't have the same number of valence electrons. So for 8, we're just going to pick 3 because they have the same number of valence electrons and they are in the same group. Good job. Good. 9. The notation for the nuclide 13755 cesium gives information about, okay, what do we get from this? We get the mass number, we get atomic number, we get both the mass number and atomic number, so 3 is going to be our answer. 10. Which pair represents 2 forms of an element in the same phase at STP but with different structures and different properties? Okay. 2 forms of an element in the same phase but different structures and different properties. Okay. When it's talking about different structures and different properties, it's gonna mean there's a different there's like a different amount in each of them. If we look at iodine, for example, we still see it's just in a different phase. We have 2 iodine still. That has the same structure. If we see hydrogen and mercury, for example, it's still in the same phase. We have, oh, no, that's not good logic. This is still probably going to, I'll get back on the third one. But for water and water, these are just 2 different phases. But let's go back to the question on this, because we're battling with O2, O3, and two completely different stuff. So it says which pair represents two forms of an element in the same phase at STP, but with different structures and different properties. Okay, so we're talking about of an element. So these elements must be the same. So we can cross out 3, and we are just left with 2. I believe O3 is like ozone, and that's oxygen, of course. 11. The elements on the periodic table the elements on the periodic table are arranged in order of increasing. Okay, let's go. Let's look at this. This is atomic number. You see these bottom numbers right here? It's just going up the atomic number. Honestly, guys, with the multiple choice especially, you can just rely everything on your reference table. That's the beauty of your reference table. So what is the IUPAC name for the compound ZnO? Okay. So this is zinc, and this is oxygen, and this is going to represent in the ionic bond. I guess we can just choose zinc, I think zinc oxide. Zinc oxide sounds good. Because, like, peroxide doesn't make sense, and hydroxide, there's no hydrogen at all, and oxalate, what the hell is the 8 part? 13. Which atom attains a stable valence electron configuration by bonding with another atom? Okay, neon, that's already a noble gas. It already has 8 valence electrons, so cross that bitch out. Radon. Where's radon? Radon, it's already a noble gas, because it doesn't need to, like, bond with anyone. Helium, that's already a noble gas, because it's too good to bond with anyone. And we're left with hydrogen, and that makes sense, because if we look at hydrogen, if we just add one more electron, it can fill their shell. Okay, we're on the next page. Almost done with part A. 14. An ionic bond can be formed when one or more electrons are... Okay, when we think of ionic, we think of transfer of electrons. So when we see shared, hell no. Unequally shared by 2 atoms, there's no sharing, no caring, bitch. Transferred from the nucleus of one atom to the nucleus of another atom. Since when did electrons, transfer to a nucleus? Like, that doesn't make sense. We're dealing with valence electrons. So transfer from the valence shell of one atom to the valence shell of another atom, bitch. Yes. T. Oh my god, I'm so cringy. 14, 4, yeah. So let's give ourselves some checkies. Okay, 15. Which sample of carbon dioxide has a definite shape and a definite volume? Okay, when we're thinking about definite volume, definite shape, that means they have a shape. That means they have a volume. So when they have a shape, when they have a volume, bitch, that's a solid. See, just like this carbon dioxide phase, you're going to be solid at chemistry. 16. What occurs in order to break the bond in a Cl2 molecule? When we are breaking a bond, energy needs to be freaking absorbed. So, like, watch my fingers. So, here's a bond. Energy needs to be absorbed to break it. Okay? Yeah. I suck at teaching. Okay. So, energy needs to be absorbed in order to break it. It's like when you're in a relationship, and in order to, like, break up with that person, you need to, like, give the energy, give them the talk that you're going to actually break up with them. So, 17. A sealed, rigid 1-liter cylinder contains helium gas at STP. An identical sealed cylinder contains neon gas at STP. These 2 cylinders contain the same number of... Okay, so they are in the same, this is Avogadro's constant and all that ish. So we're gonna say atoms, because if they're in the same volume container, they're gonna have the same number of atoms, okay? So, yepperoo. 18. Which statement describes a chemical change? When we're thinking chemical change, we are seeing colors change. We are having smells. We are having completely different products. Okay, so alcohol evaporates. Bitch, no, evaporation is not a chemical change. That's physical. Water vapor forms snowflakes. Again, physical. Physical. Time to get physical. Anyways, table salt is crushed into powder. We still got the table salt. It's still salty. Glucose and oxygen produce carbon dioxide and water. That is a chemical one because we have a completely different product. Because of glucose and oxygen, they are reacting with each other. 18 is 4. 19. Which statement describes the particles of an ideal gas according to the kinetic molecular theory? Okay, when we think of ideal gases, they want to be free, they want the temperature to be really high, they want the pressure to be really low. Okay, so the gas particles are arranged in a regular geometric pattern. Okay, gas particles are never gonna look like this. Gas isn't perfect. That's why farts smell. So, no. The gas particles are in random constant straight line motion. Yeah, gas particles are random. The gas particles are separated by very small distances relative to their sizes. I don't know. The gas particles are strongly attracted to each other. That's literally the opposite of what a gas particle is. So 19 is going to be 2. Okay. 20. Which sample of matter is classified as a substance? Air, ammonia, milk, seawater. Okay. Air, that's not a substance. Ammonia, I know pneumonia, but I think ammonia is like some sort of, isn't that like in your pee or something? I don't know. That's like a compound. Seawater, that's like water. That's a liquid. That's not an actual like substance. So I'm gonna go for 20. I'm actually going to go for ammonia. You know why? Because ammonia is a compound, and compounds are substances. Like, a substance is made of multiple things. Like, milk, I don't see the correlation with that, because, like, milk, again, is in the liquid kind of thing. I'm not too sure about that. I would, like, talk to your teacher. But for this, like, the best answer would be ammonia, because if you look on your reference table, I think that's a polyatomic ion, and substances are comprised of compounds. See, ammonium, same thing. Anyways. 21. Which element has the lowest electronegativity value? Okay, when we think of electronegativity, we think of the desire to gain electrons. But, in this case, I guess we can just compare the electronegativities, which is given on table S. But, let's just look at some pictures of this reference table and see, visualize it. So, lowest electronegativity means the desire to gain electrons. So, fluorine is going to have a very high electronegativity because it's so close to gaining a perfect 2 shells. Like a second shell. So, fluorine is not going to be it. Francium, Franny, if we look over here, it's going to have a very low electronegativity right here because it's going to want to, give up that 1 electron. So, you know what? We're just going to be frisky with it, and we're going to say francium because nothing can beat good old Franny. 21 is 2, yeah. At standard pressure, CH4 boils at 112 K and water boils at 373 K. What accounts for the higher boiling point of H2O at standard pressure? Okay, guys, remember this. The reason for a high boiling point in water is because of the hydrogen bonding. These hydrogen bonds, they have such a strong attraction. The hydrogen and oxygen, they are inseparable, bitch. And they're going to want to be together. And it's going to take a lot of energy and a very high temperature to break these people apart. So it's going to be, always remember, hydrogen bonding, water, high temperature, high boiling point. 22 is 3, yes. 23. A mixture of sand and table salt can be separated by filtration between the substances in the mixture because the substances in the mixture differ in solubility of water. Because, table salt dissolves really well in water, while, sand, not so much. And a little fun fact is, table salt, if it dissolves in water, salt is probably on the polar side because, dissolves like and water is polar. And sand is on the non-polar side because then, water, again, dissolves like. So, 24. Systems in nature tend to undergo changes towards... Okay, when we think of systems in nature is very lazy. They're going to want to go to lower energy. And with lower energy, that means it's going to have high entropy because the low amount of energy, there's going to be a lot of chaos because having a great amount of energy is going to keep things organized. But lower energy, there's going to be high entropy. So it's kind of like an inverse relationship. 25. In the wave mechanical model of the atom, an orbital is the most probable location of orbital. We think of electrons. Just think that, because what the hell's orbiting? The electron. The protons and neutrons, they aren't going anywhere. They're stuck in the nucleus. So 25, 4. 26. Functional groups are used to classify... Okay, just go on table R for this. It's just organic compounds. I'll show you. We just covered this. Let's go to table R. It's right here. Functional groups, right here. These help classify these. And this literally tells you these are compounds. Organic compounds. See? Organic compounds. 26, 1. Okay. 27. Which class of compounds contains at least one element from group 17 at the periodic table? Okay, so just go on table R and pick out the one element that is in group 17. And that is going to be 4 and halide. Because we got the fluorine, the chlorine, the bromine, the iodine, and all in group 17. 28. In a propanol molecule, an oxygen atom is bonded with a carbon atom. What is the total number of pairs of electrons shared between these atoms? Okay. So, with this kind of question, I'd like to draw things out because I can't think things mentally. It's weird. I can't picture things. So, we have propanol molecule, an oxygen atom is bonded with a carbon atom. We think of 3. So we have 3 C's. An oxygen atom is bonded with a carbon atom. Okay. What is the total number of pairs of electrons shared between these atoms? Okay, so I'm going to think that this is going to be a double bond. And when we say propanol, right over here, if we look, that has O and H. So H is going to go over here. And we'll just draw this out. We have H. What is the total number of pairs of electrons shared between these atoms? Okay, we have 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait. 28. It's just asking how many pairs of electrons are shared between the oxygen and the carbon. My mistake. And that's just going to be 2 bonds. Yeah, 2 pairs. But it's good to draw things out. Sorry, this keeps going out of focus. 29. When a voltaic cell operates, ions move through the ions move through the anode to the cathode. So move through the we're talking about ions. My bad. Electrons move from the anode to the cathode. Ions, they move through the salt bridge. So they can help neutralize the electrons moving from the anode to the cathode, so there isn't a power surge. 30. When dissolved in water, an Arrhenius base yields. Okay, when we think of Arrhenius, we think of we think of, what do we think of? We think of basic bitches, because those basic people, when they go to Starbucks, if you think about it, are Starbucks, and who goes to Starbucks? Basic people, basic bitches. So, when the base yields are henius, well, it tells you base in here, we think of hydroxide. And you just kind of have to like know that. It's just Arrhenius base, hydroxide, and hydronium, that's, I forgot. But just know when it says base, it'll tell you whether it's an acid or a base. Base, remember, it's going to be hydroxide. Damn, this video is too long. But thank you guys for staying with me for the 25 minutes of part A. If you give this a thumbs up, let's see if we can get this to 5 thumbs up. I will do part B. Well, I plan on doing part B anyways. So, thank you guys again so much for watching, and let's get 100 on this exam. I'll see you later.